Good day, learners. In this video, we're gonna talk about dividing monomials. Let us recall that a monomial is a single term consisting of a coefficient and one or more variables raised to a power. In dividing monomials, we need to remember the laws of exponent. One law of exponent says x to the power of m divided by x to the power of n is equal to x to the power of m minus n. Another law of exponent is x to the power of negative n is equal to 1 over x to the power of n. Example number 1. 6x to the power of 5 is divided by 3x squared. So to divide this, you can think of the numerator as 6 times x to the power of 5, and you can think of the denominator as 3 times x squared. So what we're going to do, we will divide first the numerical coefficients, and then later we will deal with the variables. So 6 divided by 3 is 2. So we write here 2. And then let's deal with the variables. We have here x to the power of 5 over x squared means x to the power of 5 is divided by x squared. So this is where the law of exponent comes in. Remember that we have something like x to the power of m over x to the power of n. In this case, we have a common base x. So what we're gonna do is we copy the common base x and then we subtract their exponents, m minus n. So that is what we're gonna do here. So we have our common base x. So what we're gonna do, we will write it here, 2 times the common base x, and then we subtract the exponents, 5 minus 2. Let's write it here, 5 minus 2. Let's continue. We write 2 times x to the power of 5 minus 2 is 3. So our final answer will be 2 times x, or that's 2x to the power of 3. So this will be our final answer. Example number 2. Negative 10 a to the power of 4 b cubed is divided by 2a squared b. So you can think of this. You can think of the numerator as negative 10 times a to the power of 4 times b cubed. You can think of the denominator as 2 times a squared times b. So what we're gonna do, we will deal first with the numerical coefficients. Negative 10 divided by 2 is negative 5. So let's write it here, negative 5 times. So let's deal with the variable a's. So we have our common base a. So we can apply the law of exponent here. We copy the common base a, and then the law of exponent says we will just subtract their exponents, 4 minus 2. So let's write it here, 4 minus 2. Then times, let's apply the law of exponent now to the variable b. So our common base is b, so we copy first the common base b, and then we will subtract their exponents, 3 minus an imaginary 1 here. So that's 3 minus 1. Let's continue. Copy negative 5, then times a to the power of 4 minus 2 is 2, and then times b to the power of 3 minus 1 is also 2. For our final answer, we have negative 5 a squared b squared. This will be our final answer. Example number 3. 12x to the power of 4 divided by 4x squared. So again, you can think of the numerator as 12 times x to the power of 4 over you can think of the denominator as 4 times x squared. So again, we will deal first with the numerical coefficients. 12 divided by 4 is 3 times, for the variables, we will use the law of exponent. We have our common base x, so we copy the common base x, and then we subtract the exponents. We write first the one on top, 4, and then minus the one at the bottom, 2. So that's 4 minus 2. And then we continue, 3 times the variable x. Then we have 4 minus 2 is 2. So for our final answer, we have 3x squared. This will be our final answer. Example number 4. Negative 20 a to the power of 5 b squared is divided by 5a cubed b. So to answer this, again, you can think of the numerator as negative 20 times a to the power of 5 times b squared over the denominator. You can think of it as 5 times a cubed times b. So we will divide first the numerical coefficients. Negative 20 divided by 5 is negative 4. So let's write it here, negative 4 times a to the power of 5 divided by a cubed. We copy the common base a, and then we subtract their exponents. 5 minus 3. Let's write it here, 5 minus 3 times. So remember, the b in the denominator has an imaginary 1 as an exponent. So let's deal with the variable b. Copy the common base b, and then we subtract their exponents. 2 minus 1. 2 minus 1. Let's continue. Let's copy negative 4 times a to the power of 5 minus 3 is 2 times b to the power of 2 minus 1 is 1. So for our final answer, we'll write negative 4, and then let's write a squared and then b. So we do not have to write the exponent 1 since it's gonna be an imaginary number. That's just a special way of how we write the exponent 1. So this is gonna be our final answer. Example number 5. 35x to the power of 6 y cubed is divided by 20 x squared y. So again, you can think of the numerator as 35 times x to the power of 6 times y cubed, and then you can think of the denominator as 20 times x squared times y. So let's deal first with the numerical coefficients. 35 divided by 20. So what we can do here is we can reduce this fraction into lowest term. So you think of a number that can divide 35 and 20 evenly. So we can use 5. 35 divided by 5 is 7, and 20 divided by 5 is 4. So we have 7 over 4 times. Let's deal with the variable x. Copy the common base x, and then we subtract their exponents. 6 minus 2. Let's write it here, 6 minus 2 times. Now let's deal with the variable y. Now remember, we have an imaginary 1 here. So we copy the common base y and then we subtract their exponents, 3 minus 1. Let's write it here, 3 minus 1. Let's continue. So we have 7 over 4 times x to the power of 6 minus 2 is 4 times y to the power of 3 minus 1 is 2. So our answer will be 7 over 4 x to the power of 4 y squared. This is already an answer, but there's also another way on how you can write this. You can write this as 7x to the power of 4 y squared all over 4. This is also a correct answer. So either of the two is correct. Example number 6. 12x to the power of 7 y to the power of 5 is divided by 20x cubed y squared. So to answer this, the same as we did before, you can think of the numerator as 12 times x to the power of 7 times y to the power of 5, and we can think of the denominator as 20 times x cubed times y squared. So let's deal first with the numerical coefficients. We have here 12 over 20. So what we can do here is we can reduce 12 over 20 into lowest term. So we think of a number that can divide 12 and 20 evenly. So what number is that? We can use the number 4. 12 divided by 4 is 3, and then 20 divided by 4 is 5. So we have the fraction 3 over 5, or 3/5. Let's write it here, 3 over 5 times. Now let's deal with the variable x. We copy the common base x, and then we subtract their exponents, 7 minus 3. Let's write it here, 7 minus 3 times. Now let's deal with the variable y. We copy the common base y, and then we subtract their exponents, 5 minus 2. Let's write it here, 5 minus 2. Let's continue. Let's copy 3 over 5 times x to the power of 7 minus 3. That's 4 times y to the power of 5 minus 2. That's 3. Simplify further. We have 3 over 5 x to the power of 4 y to the power of 3. This is already a correct answer, but there is another way to write this. You can also write this as 3x to the power of 4 y cubed all over 5. So this is also a correct answer. Either of the two is correct. Example number 7. 45a to the power of 6 b cubed is divided by 15a squared b to the power of 5. So to answer this, we do the same thing. We can think of the numerator as 45 times a to the power of 6 times b cubed, and we can think of the denominator as 15 times a squared times b to the power of 5. So what we're gonna do, we will deal first with the numerical coefficients. 45 divided by 15 is 3 times. We deal with the variable a. We copy the common base a, and then we subtract their exponents, 6 minus 2. Let's write it here, 6 minus 2 times. Now let's deal with the variable b. We copy the common base b, and then we subtract the exponents. Remember, the one on top comes first, so we write 3 minus 5. Let's continue. So that's 3 times a to the power of 6 minus 2 is 4 times b to the power of 3 minus 5 is negative 2. So now we have a negative exponent. how do we deal with the negative exponent? Let us recall the laws of exponent, which says x to the power of negative m is equal to 1 over x to the power of m. So what just happened here is that the whole expression was brought down to the denominator, and then the negative exponent became a positive. So that is what we're gonna do here. Let's copy 3 times a to the power of 4 times. So what will happen to b to the power of negative 2? We will bring it down to the denominator, so it becomes 1 over b to the power of positive 2. Notice that the negative 2 became positive 2. So let's continue. You can think of 3 as having an imaginary denominator of 1. And you can also think of a to the power of 4 as having an imaginary denominator of 1. So what we're going to do here is we will multiply all of the numerators. 3 times 1 is 3. And then 3 times a to the power of 4 is a to the power of 4. So on the numerator we have 3a to the power of 4. And then in the denominator we have 1 times 1, that's 1. And then 1 times b squared is b squared. So for our final answer, it's gonna be 3a to the power of 4 over b squared. Let's have our last example. 18x squared y cubed is divided by 54x to the power of 4 y to the power of 5. So you can think of the numerator. Again, we can think of the numerator as 18 times x squared times y cubed. And we can think of the denominator as 54 times x to the power of 4 times y to the power of 5. So 18 over 54. What we can do here is we can reduce this to lowest term. You think of a number that can divide 18 and 54. So we can use the number 18. 18 divided by 18 is 1, and 54 divided by 18 is 3. So we have 1 over 3 times x squared over x to the power of 4. So we copy the common base x, and then we divide exponents. Remember, the one on top comes first. So that's 2 minus 4 times, let's deal with the y variable. Copy the common base y, and then the one on top comes first. So that's 3 minus 5. Let's continue. We have 1 over 3 times x to the power of 2 minus 4 is negative 2 times y to the power of 3 minus 5 is also negative 2. So now we have negative exponents. So how do we deal with them? We bring them to the denominator. So we have 1/3 times, we bring x to the power of negative 2 to the denominator, so it becomes 1 over x squared times y to the power of negative 2 becomes 1 over y squared. So let's multiply all of the numerators. 1 times 1 times 1, that's 1 over, let's multiply all of the denominators. 3 times x squared times y squared, so that's 3x squared y squared. This will be our final answer. For your activity, we have here 10 items for you to work on, so feel free to play again the video from the beginning so you'll have a good idea on how to answer this. So if you find this video helpful, please do me a favor and subscribe, like, and also share this video so that we will be able to reach as many learners as possible. And also do not forget to hit the notification bell so that you will be updated whenever we will add a new video in our channel. You can also visit our channel and check out some of the math lessons that can help you. So thank you guys for watching, and see you all on our next video.